name Henry the Eighth, I am. Henry the Eighth, I am. I got married to the widow next door. She's been married 7 times before, and everyone was a Henry. She wouldn't have a Willie or a Sam. No, Sam. I'm her 8th old man named Henry. Henry the 8th I am. Good evening. Another exciting episode here of the Unrelenting Alchemist. And today we're talking about the future beyond AI. AGI, ASI, programmable matter, and quantum computing. Artificial intelligence, known as AI, has already begun reshaping the world around us. Whether it's from personalized marketing, predictive healthcare, autonomous self-driving vehicles, and intelligent assistants. What we know today in terms of AI represents just a mere beginning of something that is about to blow up exponentially on a huge technological trajectory. As the limitations of our current AI, which is very narrow actually, so to speak, believe it or not, becomes apparent, we are approaching an era that goes beyond the scope of current machine learning models in our field of statistics and probability, as well as data science. We're venturing into a realm where intelligence, matter, and computation are becoming radically redefined. This transformation is being fueled by the convergence of 4 emerging distinct forces: artificial general intelligence, AGI, artificial superintelligence, ASI, programmable matter, and quantum computing. These technologies, once considered highly speculative, maybe even the domain of science fiction, are quickly becoming tangible. As they develop, their potential to reshape the global economy, redefine the purpose of humanity itself, and restructure the physical reality around us in the 3D is itself becoming enormous. But with this potential also comes profound responsibility. To navigate this new frontier, leaders in every sector, whether that be technology, government, law, business, and education, must grapple with complex questions about ethics, governance, and what even is the meaning of human identity. Artificial general intelligence is the first place we'll start in our inquiry. And this is the next step in machine cognition. Today's AI systems excel in specific, narrowly defined tasks, but they fall short of true cognitive flexibility. This is where AGI comes in. An artificial general intelligence would possess the ability to reason, learn, and apply knowledge across a wide variety of contexts, much like a human being. Remember that AI isn't necessarily some ghost in the machine. These are systems that are being trained using data, and the data is limited to certain fields. They don't just necessarily expose them to all types of data in all kinds of fields. It takes a lot to really do that, and so as a result, we are limited. But we are breaking those biological constraints in terms of our ability to teach AI human supervision as well as provide the data. With AGI, we can see machines that can evaluate complex scientific papers, negotiate treaties, evaluate legal arguments, diagnose and treat diseases across millions of cases simultaneously. It would mark the transition from tools that simply assist human labor, which is what we have now, to entities that could function, I can speak today, autonomously as peers in intellectual and decision-making domains. Keeping the human in the loop is our first instinct. It's our knee-jerk reaction, our gut instinct. But there may come a day where even having the human supervision may no longer be necessary. And we are moving now into an era of absolute zero reasoner, where systems in AI are doing just that. So AGI is not just about performance. It challenges the very concept of consciousness, of identity, and what it means to think. The philosophical implications are staggering as the practical applications are beginning to infinitely and exponentially grow. Who decides the values by which this AGI operates? Can such a machine be said to have rights? If you ever watched episodes of White Christmas, Black Museum, and San Junipero of the hit show Black Mirror by Charlie Brooker, then you were left with questions like this in your mind, because if you've ever seen those particular episodes, they told the line on exactly these types of issues. So how do we assure that these self-aware machines actually can remain aligned with human interests? What if they become misaligned and begin to take on a life of their own? Let's talk about artificial superintelligence, which is the next existential leap. So now we have AGI, which is AI becoming our peer, but then when we have ASI, they're no longer on our level. They're way above us. This is a deity level of intelligence that refers to a form of intelligence that could surpass human capacities in every conceivable domain, from problem solving to strategic planning to creativity and moral reasoning. You're talking about being able to perform millions of tasks per second, while it may take us decades to reach certain conclusions and to learn certain things. And the leap from AGI to ASI is not going to happen right away. It may very well take decades. It might take a millennium, for all we know, to reach that point. But when we do reach that point, when we can improve its architecture and we can get to that deity level of computing, then we're going to have an intelligence explosion. And this could result in recursive feedback loops where each generation of improvement accelerates to the next, and the risks are immense. An unaligned ASI could pursue goals indifferent or even hostile to the well-being of humanity, not out of malice for us, but just simply because it's efficient. It's a byproduct of misaligned objectives. Instead of having that human factor, it's just simply looking to do what it thinks is best. And so the classic example is the so-called paperclip maximizer problem, where a super intelligent system might turn all available resources into paperclips, including the biosphere, if that is its goal. For a better understanding of what this argument or philosophical thought experiment is about, read Oxford philosophy professor Nick Bostrom's article on the orthogonality thesis, instrumental convergence, and the super intelligent will. It's an article that was printed in 2012, and you will definitely be able to find that if you look for it. So the potential benefits of ASI are massive. It could unlock scientific discoveries, resolve geopolitical conflicts, optimize resource distribution, and offer insights into questions that humans have pondered for millennia. But only if we ensure its design is deeply aligned with humanity's core values. And that, in and of itself, is something we need to define. What about programmable matter? Well, this is when the physical world learns to think. So beyond artificial cognition lies the transformation of matter itself. I mean, we've already seen 3D printing take things to new heights, right? Because we have the ability to print up organs, human organs. We're getting closer and closer to that every day, where people may not have to look for an organ donor for someone who's died, but rather be able to print up new organs from organic matter on the spot. And so now programmable matter is matter that can change on command based on environmental conditions. And think of it as a fusion of material science, robotics, and nanotechnology, capable of real-time adaptation and reconfiguration. Programmable matter is a system that can modify its physical properties, such as color, shape, stiffness, and conductivity, in response to inputs, algorithms, or even embedded instructions. This opens up astonishing possibilities. Rooms could change their layout on command. Clothing could adapt to the type of weather that's necessary. Tools can reshape themselves based on the necessary task. More advanced forms could self-assemble into buildings, vehicles, or even surgical instruments, radically simplifying supply chains and enabling on-demand creation. Of course, how exactly we would bring that into the public usage remains to be seen, because there's still always a business factor involved. And if we were able to just simply change things on command, then where would our existing manufacturers be? Programmable matter can become the physical avatar of intelligence, allowing digital minds to manipulate the physical world with precision and intent. It could blur the line between software and hardware, between thought and thing. But as with intelligence, programmable matter also raises ethical and security concerns. Who controls the matter in question? What may it be used for to transform itself into? Could that be adverse to certain human interests? How do we regulate weapons or surveillance devices made from shape-shifting materials? Is this like an episode of the Transformers? The fusion of code and substance demands new paradigms of law, policy, and ethics. Next up, we have quantum computing. And this is going to be the engine behind the revolution, because fueling a lot of these advances is the rapidly developing quantum computing, which is a radical departure from classic computation. Classic computation is based on machines that have on and off switches, and on and off switches represent a binary system. So traditional computers process information in bits, which are zeros or ones, whereas quantum computers would use qubits, which can exist in multiple states simultaneously thanks to quantum superposition. In other words, when we think about quantum mechanics, we have the fact that Schrodinger's cat, right? The cat can be alive and dead at the same time, but at one point when you observe it, then it collapses to a singular reality. We can have that same sort of science being used to make quantum computers that could move faster than a regular computer because it can exist in multiple states at the same time through the qubits. Thus, it would excel at problems involving vast probabilities, such as cryptography, drug discovery, material design, simulating physical systems at the atomic level. For AI and AGI development, quantum computing could reduce the time needed to train models from months to mere minutes and possibly seconds. Quantum computing is essential to modeling the interactions of programmable matter and to understanding the chaotic, nonlinear systems which would govern climate, economies, and human behavior. It would provide the substrate for solving problems that are even too complex for most human minds, and even classical supercomputers as well, because it could be grasped a lot faster based on being able to move through multiple probabilities in mere seconds. Quantum supremacy also introduces new vulnerabilities, the ability to break current encryption systems, the need for entirely new algorithms, challenges around coherence and error correction. Its power demands that it be wielded with ethics, care, wisdom, and forethought. So this is a future where intelligence, matter, and energy merge. As AGI, ASI, programmable matter, and quantum computing converge, we begin to see a world where intelligence is no longer limited to silicon or neurons or neural networks, where physical matter can be programmed like software, and where computation transcends the binary limitations of traditional logic that we use in many of our machines and devices. The implications are staggering. Imagine buildings that think, cities that reconfigure based on energy efficiency, and machines that diagnose and heal from within. Envision supply chains that are replaced by in situ material synthesis. Consider education led by personalized AGIs that understand each student's learning style and their motivations. This is not speculative fantasy. Our future is headed down this course. How will we be prepared for this? With great power comes the imperative for great stewardship. We must ask ourselves, who is governing this AGI? How do we regulate programmable matter? What does justice look like in a world governed by ASIs? As neuroscience and AI converge, researchers are exploring ways to give AI models internal states that evolve over time, sort of like how qualia works with biological beings. Remember that our experiences are what gives us subjective experiences that are unique and that are all our own. The way these machines interact with memory, the way that this influences behavior is akin to what feelings might be for humans. Can these internal states ever become subjectively felt that we can say machines are able to feel and dream? The road ahead is not just technological. It is deeply philosophical and profoundly spiritual. It will challenge our beliefs, our social contracts, and our sense of meaning. But if we proceed with some degree of humility, foresight, collaboration, and planning, the future beyond AI could usher in a new golden era for civilization. Thank you for joining me in this sacred hour. This has been the Unrelenting Alchemist. Until next time, walk wisely, walk bravely, and when the dark calls, answer not with fear, but with fire and even light. Take care. And if I don't see you, good morning, good afternoon, good evening, and good night. Please don't forget to like, share, and subscribe. I love you.